Now let us discuss this deflection of a cantilever beam with a point load at its free end. Okay, let me just draw a beam now first. A cantilever beam, I am just trying to draw it out. I have a load here W at its free end. I will call this one as AB. Let this length be L. AB is equal to L. Right. So what I will do is I will try to take a section over here. I will just draw a section here XX. And this distance I will call as X. Okay, now what will happen to this beam under the action of this load? This beam will bend like this, is it not? So I want to find out what is this maximum deflection. Okay, this is the deflection I want to find out, delta, and also I want to find out what is the deflection at this, a general equation, right? We know from our previous discussions for the deflection of a beam there is a equation. That equation is EI into d square y by dx square. This is equal to m. We know this equation. Now from this picture you can see I can find out bending moment at xx. What is the bending moment at xx? Moment at x is equal to w multiplied by x, force into perpendicular distance. Since it is trying to bend the beam down, it is negative sign. Okay. Now let us equate these two equations. So now what can I write? I can easily write EI into d square y by dx square is equal to minus wx. Okay, this is what I have. Let me try to change the thickness of the this one. Okay, now let us try to integrate this. Okay, if I try to integrate it, what will happen now? Let me make integration. If I make integration, if I integrate, thickness is too small. Let's try to make it little big. Okay, by integrating, E and I are constant, so I can take it out. E into I is integral of d square y by dx square into dx. There is a constant here. That constant I will take on the right side. Minus w integral of x into dx. When I do the integration, what I am getting now? I will get EI into dy by dx. I will have a constant. I will take it onto the right side. Minus w into what I will have? X square by 2 plus C1 I will call. Okay, this is a C1 is a constant, which is the sum of constant of the left side and right side put together. This is the resultant constant, let us say. Okay, so now what shall I do now? Now I will put the boundary conditions. What are the boundary conditions? Let us see what are the boundary conditions. Now see here, if I come to this point, what will happen now? If I am coming here, dy by dx, when my dy by dx is 0, my dy by dx is 0 at this point. That is, there is no slope here. You can see at point A, the beam is horizontal, is it not? So what can I write? I can write dy by at x is equal to L, dy by dx is equal to what? Dy by dx is equal to 0, is it not? So let me write now. So if I write, what will happen? 0 is equal to minus WL square by 2 plus C1. So what can I do now? Therefore, C1 is equal to WL square by 2. So now I have what? I already have the value of what? I already have the value of C1. Now if I take this value of C1 and put it back into what? Put it back into my equation here, then what I will get? I will get EI into dy by dx is equal to minus wx square by 2 plus wl square by 2. This is what? This is my equation of slope. Okay, this is equation number 1 I will call. Now integrate again. If you integrate again, what we will get? Integrate again, if you integrate again, you will get EI into Y is equal to, let me write it, okay. Let me just put the values there first. So I will write again EI integral of what? dy by dx into dx is equal to minus w by 2 integral of x square dx plus wl square by 2, everything is constant, integral of dx, is it not? So now this will become what? EI into y is equal to minus wx cube by 3. 3 into 2 is becomes 6. Okay. Plus wl square by 2 into integral of dx is what? X, is it not? X plus c2. Now let me again put the boundary conditions. What are the boundary conditions? Where the value of y will become 0, the value of y will again become 0 at point A only. See here, the beam is fixed there, is it not? So y is 0 there. Now let's just go down. I will simply say at, let me change the color just for the sake of clarity. At, oh, it's too thick. At x is equal to L, y is equal to 0, is it not? At x is equal to L, y is equal to 0. So now what I will do now, I will just say 0 is equal to minus w L cube by 6 plus WL square, and x, instead of x I am putting L, so it will become WL cube by 2 plus C2. Okay, therefore C2 will become is equal to how much? C2 will become is equal to WL cube by 6 minus WL cube by 2. Okay, so then what will be the value of C2 now? The value of C2 would be, let's make the calculations. The value of C2 will become WL cube by 3 with a minus m. Therefore, C2 is equal to WL cube by 3 with a minus sign. Now take this one and put it back into the equation. So I will have EI into Y is equal to minus WX cube by 6 plus WL square by 2 into X. Instead of C2, I will have WL cube by 3. Okay. This is what? This is the value of what? This is the value of X I am having. I'm sorry, EI into Y I am having. Okay. Now, when your value of Y will be maximum, Y is maximum when X is 0. Y is maximum when X is equal to 0. See, let's just go back. Let's go back and see here. Now, see here. This is maximum here, is it not? When X becomes 0, then only it becomes maximum, because we are measuring X from B. So now if you put the value here, then what will happen to the value of Y max? Y max will be is equal to 1 by EI, bring it down, 1 by EI multiplied by, here this becomes 0, first term, second term becomes 0 into W L cube by 3 with a minus sign. So therefore I can write Y max is equal to minus WL cube by 3EI. This is the formula for what? This is the formula for your maximum stress, I mean maximum deflection, understand? And dy by dx is also maximum when your x is equal to 0. Let me just go back here, Because I don't have space, I will just write it on the side. I will just change the color to some other color which is a bit different compared to these colors. Which one shall I choose? Let me choose green and make the thickness little less. Okay. dy by dx is max when x is equal to 0. If you put in equation 1, then what will happen? Dy by dx is equal to wl square by 2ei. Okay, this is the maximum dy by dx. This is maximum value. You have one maximum value here and you have another maximum value in the bottom. Okay, this is y max. Understand? So this is for what? This is for cantilever beam subjected to a point load at its free end.